Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you wherever you are in this part of this globe. And as you know, this is the DADM free course, which is data analysis and decision making free under the NPTEL MOOC series. And this total course duration is basically contact hours is 30, which when broken into number of lectures is 16 number, because each lecture is for half an hour and that is spread over 12 weeks, and after each week you have each week consisting of 5 lectures of half an hour each, you have one assignment. And we, as you can see, and total assignments would be 12 in number, as you can soon come to know in the next slide. We have once completed 7 weeks, which means 5 assignments are over, and we are going to start the 8th one. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, this is the lecture number 36, which is the 8th week, and we will discuss something to more with linear programming for an application side and then go into the nonlinear part. So, this concept of data and envelope analysis we have considered in DADM 2. I will go into the details. Before, if you remember, we did discuss about the formulation and the idea that how you solve it using the operation research techniques would be considered now in a little bit more details. But the methodology of solving operation research or simple optimization problem using linear programming you are already aware. So, consider you have a system, or consider you have some decision making units. So, why DA is utilized, data envelopment? That means you have some data based on which you formulate an envelope in generally in a 2-dimensional space in a Cartesian coordinate, and what are the x axis and what are the y axis. I am going to come to that within few minutes. So, say for example, you want to analyze that how a hospital is doing, or how a set of hospitals are doing, or how a company, a set of factories of a company is doing, or say for example, how the government is functioning, different state governments in India are functioning, or how different type of IITs or IIMs taken collectively or as different entities are doing. And when we consider that how they are doing, we are trying to basically find out that considering the overall set of inputs and overall set of outputs, that how well we have been able to utilize this inputs and outputs to arrive at some rational decision. Rational decision means about the ranking. Now, these consider that if you have the IITs, and if you consider only the first earlier IITs, and consider there are Kharagpur, it is Kanpur, Madras, Delhi, Bombay, then you consider Roorkee, and also you consider Guwahati. We want to basically find out that considering the inputs, what are the inputs here? The question would be that, say for example, the number of faculty members, the training of the faculty members, how many papers they are publishing, what is the total number of grants they are getting, what is the total quantum in the monetary terms, the MDPs they are doing, what type of consultancies they are doing, then what type of teaching they are doing. Inputs can be, say for example, the students, the ranking of the students, the quality of the student considering from which background they are coming. It can be the infrastructure can be the input, how good the library is, how good the research labs are, how good the core labs are. It can be, say for example, how good the environment is, what type of recreation facilities they are. The staff could also be considered as an input, how efficient they are. So, whenever you are considering the inputs, there would be a set of inputs which are parametric in nature. You have basically some equational format, some monetary values, some units are there, and you can basically find the total input in quantum terms. But there may be some inputs which you cannot find out in quantum terms, is that if you are considering, say for example, the type of students who are coming, leave aside their ranking in the JEE main or the JEE advanced, we will consider that if they are coming from different strata of the society, from different economically poor background. So, obviously, we will consider that as some subjective input, which would definitely be considered as one of the inputs when you are trying to basically collectively find out the input bundle in order to basically rank this different type of IITs or the decision making units, which we will call the DMUs. Now, on the other hand, the outputs can be, say for example, what is the total number of companies which are visiting the institutes, what is the median salary, how many students have been placed, what is the type of Indian companies which are recruiting people, how many female candidates have been placed. Obviously, we can consider the female candidates as the input also, considering that there is a thrust area in the education system to basically put more weightages, that the number of female students who graduate in the technical education should be much higher. Then the output can be what is the research quantum of the students who are publishing, the quality of MTech thesis, whether the MTech thesis are being published, whether the students are going for higher studies, whether the students are going for, say for example, PhD students going for postdoctoral position, what type of employment these PhD students are getting into different IITs, NITs and technical CFTIs. So, here also the number of outputs can either be quantified in monetary terms, in some units, in some mathematical terms, and there would be some outputs which cannot be done likewise. So, obviously, you will have some sets of outputs which are subjective and some sets of outputs which are objective. So, you would basically like to combine both the inputs subjective objective to get some output which is subjective objective, and then basically combine the inputs and combine the outputs, try to find a ratio, try to find an average, and then rank the inputs or the outputs combined together such that we get a ranking system. Now, as I said that this type of data environmental analysis can be also be utilized for hospitals. So, the hospitals would be say for example, what is the number of beds which the hospital has, type of different type of operation theatres which are there, what type quality of services they are, what is the ICU number of patients who can be admitted, what are the type of nurses, whether they are well trained, what are the type of doctors, number of doctors, what are their degrees. Then inputs can be how many people are being admitted on a daily on an average basis, and the outputs can be like, say for example, it can be number of successful operations which are there, number of successful complicated medical cases which the hospital has been able to diagnose, or the average number of stay or general patient has to stay in the hospital, because lower number of days the patient has to stay and he or she recuperates and leaves the hospital, it is a positive mark for the nursing home. Then it will also mean that what are the number of different type of patients from different state of the society the hospital is able to cater to, whether it may be also be possible that what is the total amount on an average which is required for, say for example, an appendix operation or any heart surgery. If they are very low, obviously it would mean that many of the people who are being admitted in general from the society would be able to meet the cost in order to be medically treated. And similarly, we can give examples for the governments. So, it can be, say for example, number outputs would be a type of roads which are there, electricity has been supplied, the drinking water, education, inputs may be taxes, maybe efficiency of the administrators. The output can be, say for example, how fast the garbage cleaning system is there, so on and so forth. So, in the first example which I gave for the school, second for the hospitals, and third for the government institutes or the state governments or the municipality or the corporation, we whatever examples or inputs and outputs we have discussed, there would be some sets of inputs which will be subjective, some set of inputs will be objective. Similar would be the case for the outputs which will be subjective and objective. So, we are basically trying to analyze some non-parametric methodology of trying to rank the different type of DMUs, and here we will see how we can utilize the concept of linear programming and optimization to solve such simple problems. So, with this background, let us come to the slide. So, it says that consider you have a system or the so called decision making units or DMUs which takes some inputs, bundle of inputs, processes them, whatever the processing things are. For a factory, it would be doing some manufacturing process, it can be grinding, it can be shaping, it can be like trying to basically do the different type of smithy work and all these things, or in the school it can be the training with the student undergoes, the teaching of the subjects which the student undergoes. and for the hospital it would basically be the different type of medication the patient undergoes and so on and so forth. So, once you process them you produce some outputs, and the outputs I have already discussed. So, examples of systems or DMUs can be the machine, a factory, a hospital, as I said, an airport, it can be a university, as I have said, at the IITs starting from Kanpur, Kharagpur, Kanpur, Madras, Mumbai, Delhi, Roorkee and Guwahati. Invariably there may be many such similar systems or DMUs, examples which I already have given. It can be the banks also, like if you are trying to basically consider the Indian public sector banks. So, need not the banks, the main motive need not be profit, it main focus could be to cater to the mass population in the country, where they want to spread the concept that people can deposit their money in the banks, put in, go into fixed deposit, go into recurring deposits and utilize the loans like car loans, personal loans, house loan, education loans, in order to basically understand that how the utilize the banking system to the maximum possible extent. And then when you are trying to basically consider, for an example, SBI or PNB or Allahabad Bank. So, there the profit motive may not be the main reason based on which you will try to rank the banks. I am talking about the public banks, public sector banks. So, invariably there may be many such similar systems or DMUs which takes as input the same types of the set of inputs in different quantum, in different numbers of values, process them and produces the outputs also in different quantums. In such cases we are required to find out what is the rate of processing of these inputs and in order to produce the outputs, or what is the efficiency of the system. Efficiency means in general terms you will use the very simple definition of efficiency also. So, that we can compare them means the DMUs amongst themselves, and also find out to what degree they are deficient or there is inefficiency in the DMUs. And when we are trying to compare these DMUs with respect to the so called efficient ones. So, obviously, there would be a lack of efficiency, fall in the efficiency, we will try to basically compare the inefficient DMUs with respect to the efficient DMUs. So, that means let me read it. So, our main study would be to what degree means the DMUs which are deficient or inefficient. So, they are deficient when compared to the so called ideal system or the fully efficient system or an efficient DMUs, and how we compare them. So, we will basically have a nomenclature. So, what is the nomenclature? We will consider the number of inputs. Distinct inputs are M in number, M as in Mangalore or Mumbai. The N would be the number of outputs, which N as in nose or in Nagpur. K would be the number of DMUs, and X would basically be given by the concept of X suffix ik, where I would be the ith DMU, where I is equal to 1 to m, where it will be 1 to m, right. I am sorry, not the DMU, it will be the input concept. So, I 1 to m would be the input variable for the kth DMU, where k is equal to 1 to capital K, and this I, m, I, j and k are all small, while y suffix jk would be the corresponding to the jth, j is equal to 1 to n output or variable for the kth DMU, where k is equal to 1 to capital K. Correspondingly, we will have weights. So, the weights will be given as u I k, which will be the corresponding input weights corresponding to the x I k decision variables, and similarly for the output would be you also will have v j k suffix j k, with j again being 1 to n and k is equal to 1 to capital K, and these would be the output weights corresponding to the y j k output decision variables which we have. Before we go into the concept of trying to basically analyze the problem in a very simplistic operational research framework or optimization problem. So, we will consider the 3 different types of concept of production returns. So, what type of production return, what type of economic environment it will have. So, one will basically mention as the increasing return to scale. That means, the more you produce per unit, more is the per unit profit you are going to get. So, you will basically try to increase your production to higher and higher levels, because the per unit profit will keep increasing. So, keep increasing, the word which I am going to, which I just used, will make sense when we come to the simple mathematical concept which we will just discuss. The second concept is the decreasing return to scale or the DRTS, where more you produce per unit output will start decreasing, and this would be in the areas when the economy is not doing well. Any extra production would only increase your fixed cost, the returns would start falling as you add more and more units to the sales. The last one will be the constant return to scales, which is CRTS, and here you will consider that any additional input which you are going to make, the quantum of additional profit or revenues minus cost, whatever you think it is per unit return you will get, would be on a constant scale. The first is increasing per unit addition, second is decreasing per unit addition, and third one is constant per unit addition. So, we will try to basically analyze our DA concept under this framework. But before going into the into DA framework or DA optimization problem in the simplistic sense, I will basically go through simplistic, very simple diagrams for the increasing return to scale, which is IRTS, decreasing return to scale, which is DRTS, and constant return to scale, which is CRTS. So, the diagrams would basically be of the same type, but only the orientations will change and the graph overall shape will change, and that will basically give you that whether it is increasing, decreasing or constant. So, in this case just concentrate on the x axis. This has been done in the DADM2, but as it is a new course, hence I will go in the same level of depth as I have done for DADM2. So, in considering coming back to the slides, along the x axis you consider the input or input bundles, so IP. Along the y axis you consider the output, which are the output bundles, and the graph which you see, which I will mark now, I will use the highlighted yellow one. This is the graph which you see corresponding to the case where you have the decreasing return to scale. Why decreasing return to scale? So, let us concentrate on IP suffix 11, IP suffix 12. So, for IP suffix 11, so if I go, I am not going to draw it here because that will become too cluttered. So, if I go up vertically up, so IP 11 basically meets this so called a frontier at this point, and if I go vertically horizontally left, I basically come to okay, this my mistake. So, I should basically be mentioning this point later on. So, considering the input comes here, which is the point, and when I go to the left, it basically reaches the output level 11. So, generally the input output bundle is such that the DMU which I am marking here is below the efficient frontier. So, we will basically consider as inefficient. Why we are going to consider inefficient? Because if we go vertically up, we are able to reach a higher level of output based on the same level of input which we have, or else if we consider that we can maintain the same level of output if we move on to a lower level of input, if we move on to the horizontally on the left means from as you see on the graph. Now, consider the IP 12, where you have again an inefficient one, and the inefficient one basically goes up to this point. So, IP 11 I just do it in order to make things clear to you. So, consider DME 1 which is inefficient. If you go vertically up the blue line, you reach the efficient frontier. So, hence at the same level of input you are trying to increase your output. If you go horizontally left, you will reach that pink dotted lines. If you consider, you will reach this point where the electronic pointer is highlighting. That means, at the same level of output you have been able to decrease the input to the maximum possible level. Now, consider another DMU which is basically IPE. E means efficient. If you go vertically up, it obviously it will touch the efficient frontier at this point, which is where the green arrow is being basically pointing. This is just a coincidence that this this point should have been in this direction. So, the efficient one. So, it goes up. So, if you go vertically left, again the output level is efficient. Now, if you consider the DMU, so okay, now why this graph is called decreasing return to scale. So, if you consider per unit increase in the input bundle, the height of increase of the output is increasing, but is increasing at a decreasing rate. So, we will consider the dy dx is positive, but the second derivative obviously would not be positive, because in that sense that per unit additional input which you are adding will increase your output, no doubt, but the increase would be happening at a decreasing rate. So, here the graph is basically falling. So, the dy dx would definitely be increasing, but increasing at a decreasing rate. Now, if I consider the inefficient DMU. So, before going to the next graph, so if I consider the inefficient one, which is the black one. So, there are three ways it can reach the efficient frontier. There are many ways, but I will only consider three. One is basically going vertically up, one is basically going horizontally left, and one is going in the tangential direction towards the graph. So, what does the vertically up mean? Vertically up means, that means I am trying to maintain the same input, but I am trying to increase the output. If I go horizontally left, it means that I am trying to basically maintain the same output, but I am trying to decrease the input. And if I go in so called radial direction or tangential direction, this DMU will this inefficient one will try to basically reach this graph where the electronic pointer is highlighting, such that it is tangent to this graph, in the sense that there would be some proportional decrease in the input, proportional decrease in the increase in the output also, because the output initially was this. So, the output would increase by this amount and the input would basically decrease by this amount. So, that we will consider in a scenario. These three things we will understand in a scenario where in first case we are only concentrating on the output without touching the input. In the second scenario, we are only concentrating on the input without touching the output, and in the third scenario, which is the green one, tangential movement. Tangential movement, because that is the shortest distance between the inefficient one and the graph which you have. So, it will be moving in such a way that the proportional in decrease and increase in the input and the output would be such that you will be basically maintaining the same high level of efficiency, and such that you are on the efficient frontier. Now, when you are considering these three movements, that is the blue one, the pink one and the green one, they would basically be utilized in three different environments. So, if I am considering only the blue movement vertically up, you will think that here the input cannot be touched. So, you have to only concentrate on the output. In the pink one, when you are moving horizontally left, here you will consider that the output cannot be touched, only you can decrease the input, and in the green case you can basically make a so called compromise where you will decrease the input also and as well as increase the output. Now, where these problems would be applicable is that in the case, say for example, you have taken some labor, and the laborers are all, I will give you an example of the laborer also and on the machine one also, considering the laborers are all permanent staff. So, if they are permanent staff, you cannot fire them, but what you can do is that you can retrain them, train them such that at the same level of input you are basically, input means the number of laborers, the amount of cost which you are going to give to the laborers, the salaries, the benefits, so on and so forth, without putting any extra overtime, you will try to basically get the output in at a much higher scale. Or say for example, you have a machine and these machines are, some of them are not working, and you will basically repair them so that you will try to get the maximum benefit from the same set of inputs, because the inputs cannot be thrown away. That means, you cannot fire a permanent worker. That is where you are going to consider the vertically upward line. In the other way, when you consider the horizontal left direction, you will only consider the output where you can decrease the input. So, decrease in input can be, say for example, you have some permanent staff, some temporary staff. So, these temporary staffs would not be hired anymore, they would be fired depending on the labor law which is there in the state or the place where this DMUs are operating, considering that I am only taking the example of a factory or a DMU which produces some outputs considering some set of inputs. So, you will consider either doing away with some old machines or trying to basically fire some temporary workers such that you maintain the same level of output by trying to basically get or utilize the inputs at a much higher level scale. While if you are considering the green lines, it will be a combination such that you basically decrease the inputs like fire some of the workers and trying to increase the output by giving training to the extra people who are there. Now, consider the graph where you basically switch the x axis and y axis. So, here along the x axis you have the output bundles, and along the y axis you have the input or the input bundle. So, it will be again denoted by IP11, then IP12, this suffix 11 and 12 are the suffix, as correspondingly you have the output which is OP11 and the OP12. Now, remember one thing, here the DMUs which are inefficient, they would basically be decreasing the input if you go in the vertically downward direction. There the output was increasing, in the earlier graph it was increasing if you are going vertically up, here the input is decreasing if you are going vertically down. And in the other case, in the earlier graph, if you went horizontally onto the left, you basically decreased your input, and if you go horizontally onto the right, you increase your input. In the same way, if you consider this graph, if you go horizontally left, that means you will be decreasing your output, and if you go horizontally right, you will be increasing your output. So, if you consider the DMU which is inefficient, again which is this graph, the blue, the red, the black dot, you can go vertically down, the pink one, and reach the efficient frontier. So, efficient frontier you are reaching in such a way that you are maintaining the same level of output, but trying to decrease your input, because the decrease is happening here. If you go horizontally right, you are maintaining the same input and going and trying to basically increase your output. That means, you are trying to basically reach the efficient frontier by moving horizontally right, and if you move diagonally, that means you go in the direction where you reach the efficient frontier in the shortest possible time, the 90 degrees. Obviously, you will basically be combining the decrease of the input and the increase in the output in some way. So, the output will be increasing by this amount, I am using the same color red, please do not mind, and the input would basically be decreasing by this amount. So, you are decreasing the input and increasing the output. So, this we will consider the decreasing return to scale, where any additional addition of the input would basically decrease the output by per unit in some quantum. As I mentioned, dy dx is positive, but increasing at a lower rate. With this, I will end this first lecture of the 8th week and continue discussing more about the constant return to scale and increasing return to scale, and then come to the formulation of the DEA, say and explain how it is done as a ratio, and then basically reformulate that as a linear programming, and then we will follow the same procedure how you solve the problem using the linear programming problem, the Tableau format, so on and so forth. Thank you very much and have a nice day.